Sums and Sigma Notation by Justin D'Souza. The learning objective of this lesson is to use the sigma notation to compute basic summation. The keywords are summation, sigma notation. We will look into what exactly is sums and sigma notation after we know why it is used. So imagine this graph over here. You're driving a car for a certain distance. The velocity you know is 60 miles per hour or kilometers per hour, anything. And you need to compute the distance. You know the time is 2. This is time coordinate, velocity coordinate. What would be the multiplication of them both? This would be the distance, isn't it? So the distance we know is given by velocity times time. No, but actually, do you think the velocity will be constant? No, it keeps on changing, right? Really speaking, it'll be something like this. The velocity is variable. It won't, even if you try to be at 60, you will alternate at some point at least. You know, when you start the car, it'll be less, it goes high, and it changes because of traffic and other factors. So, how can we find more accurate result? The accurate result, see now, 1 second, let's go back over here. If you just multiply 60 times 2, you'll get 120, right? Now over here, it's a different thing, but 60 times 5, you'll get 300 miles as the distance. But if you say split each of this graph into rectangles, so this is a rectangle over here, you'll get plenty of rectangles. And now add up each of this area. In the sense, 60 times 1 is 60, then this is about 45, it's in the middle of 50 and 40, and then this over here is 50, again 55, 50. Add them all up, and what happens is you get 260. From 300 you got 260, which is more accurate. But now imagine if you had made more rectangles. Say you had made a smaller rectangle, smaller. You made, say, maybe 50 rectangles. It would be more accurate. So this is about accuracy. Now, the more rectangles you do, the more accurate the distance traveled would be. But that would be such an onerous task because you have to compute so many sums, right? So what you can do is you can use a sigma. Sigma is summing up a lot of numbers. So if you use sigma notation, it makes our job very easy. This is a Greek letter. If you're thinking why it's mainly Greek letters, even say alpha, omega, all these are Greek letters because many of the Greek philosophers had found a lot of initial part of math. So that's why they had given Greek letters. And now the sigma notation is summation. Okay, and this I is a very important. It's like where you start. You start from 1 till 20. So you do the process of I squaring from 1 to 20. That is the index of summation. Now we will put this all in a problem you'll understand much better. Now this is a general form of it. You keep on adding it up. So now I, the first term, whatever the function is there, I1 plus I2. And it goes on till whatever number is on the top. This I is the index of summation. And now we have a problem over here. Now if you look at this, you can see the A and B are two separate questions. The A is of square root 1, 2, 3. And it goes on till which number? 10. So now, if you start with the index of summation, if you do sigma, I will be starting at where? You start from 1 because the first number is 1 and it goes until 10. But what is the function now? Function is square root. Don't write 1, 2, 3. We are giving it as I. So this is the answer basically. That's it. This is how we write summation. Now, you can also write it as x, sorry, it's not I, 1 square root x 10. Now I'm just writing this because sometimes your questions might be in terms of x. That's the only reason I'm showing this. So this is it. Now you can try the second one by yourselves. It's very simple. It'll be starting is at 3. Okay, you started at 3 and over here it keeps on going till 45 and it is cubed. So I cube. So these would be the answers for the A and B. Very simple. So that's it. And this is it. It's a very simple and easy lesson. Now, what about this one? Write in summation notation the sum of first 200 odd positive integers. Now here, it's very important to know it's 200 odd positive integers. Not till 200. It's not say 1 to 199 because it's odd. No, they want 200 numbers. Say 1, 3, 5, 7, odd numbers, 200 like this. So we know until 200 there are only 100 odd, because say if you take 5, let's take an even number, 10 numbers. How many odd numbers are they? Divided by 2, there will only be 5 odd numbers. So we know half of that will be odd. So what we need to do is we need to take numbers until 400. So if you take 400, divide this by 2, you will have 200 odd numbers, 200 even numbers, right? So the last odd number, 400, is not odd, it's even, so we'll take it as 399. From 1 to 399. That is our goal to go. We have to find the summation, sum of all them. So now here, let's write summation. You know, we start with, say, let's start with 1. There will be how many numbers? 200 numbers if you're starting with 1. Now don't write this 400 because we need 200 numbers only, sum of 200. But now, how can we write this as 1, 3, 5, 7, and so on? Odd numbers, it's difficult, but if it was even number, we know it's 2, 4, 6, 8, 10, right? If you say x multiplied by 2, and we can consider x to be 1, 2, 3, 4, we would get even numbers, because each time you're multiplying, 2 times 1, 2, 2 times 2 will be 4, 2 times 3 is 6, and so on, right? So this is the term denotion for even numbers. Now how do we get odd? We can just add or subtract by 1. So if you add 1, it'll be odd number, because even number is this, you're adding 1, it'll be odd. Or subtract 1 will be odd. Now over here, I will take subtracted by 1 for now, and let's see this in a minute. I'll write even the plus 1 in the other equation. So now this is the equation. Let's try this. Let's figure it out whether it works. Let's substitute. Okay, I've written x. Let me just change this to x. Usually it'll be I or x. X is very rare case, but I but you know, it's fine. Now let's substitute over here. 2 times 1, it's 2, minus 1, it'll start with 1. X becomes 2. 2 times 2 is 4, minus 1, 3. 6 minus 1, 5, 7. Yes. And let's see what happens when we put 200. 2 times 200 will be 400, minus 1, 399. Yes, this is absolutely correct. Now, what do we do if it's plus? Do I write the same thing? 2x plus 1. Where do I start? I will write that as x. Where do I start and where do I end? Now here, if you're going to start at 1, what's going to happen? It'll be 2 times 1, that is 2 plus 1, it'll be 3. No, you can't start at 1, you need to start at 0. And then if you're considering 0 as a number, then you don't end at 200, because it'll be 201 numbers then. You end at 199. If it's 1 to 200, 200 digits, right? Now we are starting from 0, considering that as digit, it'll be 199. Now this will work. 2 times 0 is 0, plus 1, 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1, 5, 7, 9. And last one, 2 times 199 is 398, plus 1, 399. So these are the two answers for this. So that is how we can write. This part is important. We need to know what are the odd numbers. See, even numbers, it's very easy. It's just 2x or 2i. And then we add or subtract by 1. It's good to go with subtraction because you can easily start with 1 to 200. Just be careful with that. So this is the answer, or you can also go with this answer. Now, how do we solve these problems? Now here they have just asked you to write out all the terms. Now what's happening over here is we have summation from I equals 1 till 8 to I plus 1. So what is the first term here? You need to substitute 1 instead of I. Okay, let's start over here. 2 times 1 plus 1. Add this term with the second. I becomes 2 now. It will be 2 times 2 plus 1. And then again it will be 2 times 3 plus 1. 2 times 4 plus 1. 2 times 5 plus 1. When do I stop this? Because they have told away, write out all the terms, I'm just writing it. I'll write it down. 2 times 6 plus 1. This is the stopping number. I need to go till 8. 2 times 7 plus 1. And lastly, I have 2 times 8 plus 1. So these are all the terms. I wrote out all the terms. Now, if you sum them up, first let's simplify them. It'll be 2 times 2, 2 plus 1 is 3. Here it'll be 5, 7. They're all odd numbers basically. 9, 11, 13, 15. It's 8. So 3, there's one more. That is 17. So many. Now, if you add them all up, that would be the answer. So this is how we do it manually. Now you can try start even this one. Let me do the second one as well. Okay, I'll do all of these because they're interesting. Then we use the same thing. It's equal to 6 sine 2 pi I. Now what happens over here? Sine 2 pi, what is I? It starts with 2. That means it's 4 pi. But wait a minute. What is sine? Sine 0 is 0. Sine 0 is 0. Sine 360 is 0. Sine any multiple of pi is 0. So we know sine 0 pi or 2 pi or 4 pi, 6 pi or 5 pi, 3 pi. All these values are 0. So over here we are doing whichever multiple, there's 2 pi and you're multiplying that, right? 1 time, 2 time, 3 time, it will always be 0. Okay, so the ultimate answer would be basically 0. You don't you should write it out. Okay, you can directly write it as next one would be 3 times 2 is 6 pi, then plus sine, after 3 is 4, 4 times 2 will be 8 pi, and so on till 6 times 12 pi you need to write over here. And then when you add them all, each of them is 0, 0, 0. The final answer would be 0. So that is how we do this. And last one is a constant term. I is equal to 4 and we have 10 over here, 5. Now, is there any x over here? Is there any I? No. But if we have 4 to 10, I was doing this with my students and some of my students, not most, some of them got confused and they told it's 5 only. Doesn't matter how many times because it's just a constant, right? Or some told no, you have to just keep on multiplying this with till 10, this number. Many answers were there. The actual answer would be, let's do the same thing. 5, is there any I over here to multiply this 4? No. So we just leave over here. There is really actually the 4, then there is 5, 6, 7, 8, 9, 10. So many terms are there. First, with the 4 term, it's only 5. With the 5th term also, it's 5. Plus 5, plus 5, plus 5, plus 5, plus 5. How many 3, 6, 7? 7 5s are there. 4 to 6. You count even the 4th one. 4, 5, 6, 7, 8, 9, 10. There are 7 numbers. So it'll be 7 times 5, that is 35. This would be the answer. So this is how we basically solve these problems. Now I will show you the calculator method, which is very, very straightforward. You need to have your calculator for this. All you need to do is use the summation symbol. Can you see that over here? If you press this, you'll get log, but if you press shift and the symbol, log symbol, you get the summation symbol. Now you need to type 2i. There is no I in your calculator, it's alpha x plus 1, and over here we have 1 to the up till 8. That will be the answer, 80. I did not sum it up, but answer is 80. Now same thing, I'll do the last one, then I'll come to this. So here 2, and there is sorry, anyways, I'll do this one only, no problem. 6 over here, and we have sine. Now please use the brackets properly. Sine bracket 2 pi, that is over here, multiplied by alpha x, and close the bracket. Now if you have not closed the bracket properly, you'll get syntax error, and syntax error is always to do with the brackets. Now if you close the brackets properly, I'm getting 0 over here, but many of you may not get a 0. You will get some 1 point or some value. If you have not changed this to radian mode, then you will not get the correct answer. If you have cleared your calculator, the default will be in degrees, shift, mode, and 3. So it's in degrees, right? You'll get some value. This is wrong. You need to change it to radian mode. Now you get the answer. Oh, one of my students told, why do we need to change to radians? He kept it in degree and he just changed the pi to degrees. That's also fine. That is just to make this pi to 180. Instead of pi is 180 degrees. you can get the answer. But if you just want to copy how it is in the question and just get the answer quickly, if you want to put it pi itself, then make sure you press shift mode and press 4. That's in radians now, and now you get the answer. Okay, I'll just clear the calculator now, and then we will go to the last one, shift and sigma symbol. This is the summation. It's just phi, and we start with 4 and we go till 10, and the answer is 35. So these are the answers over here. That's it. Now we will look into the formulas. There are some theorems on how you can easily do them. So instead of taking so much time, we can easily solve them up. How do we do that? It's very simple, but you need to have these conditions over here. First, you must have the I starting at 1 for all the cases and ending at n. You can't, oh, by the way, you cannot have decimal numbers over here. You can't have 1.5. I'll show you why in a minute in the calculator. So we should have a whole number. It'll be from 1 and keeps on going. And here, so sorry, the n must be positive integer. That's what a whole number I told. So it should be a positive integer. And what about this? If it's a constant, this is the formula. That means if it's any number, let me write some examples. If you have summation I equals 1 to 5, and the number over here is 7, okay? This is a constant, right? Constant C multiplied by n. That means it will be 7, n is this 5, that is 35. That would be the answer. Now, if it is, say I'll write it over here itself, summation I should start from 1 and it ends at say 5. And you have only I. Then it's very simple. What is n? N is 5 times 5 plus 1 would be 6 divided by 2. That would be 6 times 15. 2, 3. 3 times 5 is 15. So this would be the answer. And the last case would be if it is power 2 over here. Then you have this 5 into one number greater than that, and then you need to multiply 2n plus 1. Just remember that. So over here, n is this, 2 times this is 10 plus 1 will be 11 divided by 6 over here. Okay, so this cancels. 5 times 11 is 55 is the summation of this. So this is how we basically find these answers. See, now this conditions must be met. Only then you can use those formulas. Now, if you're thinking, what if it is starting at 3 and over here it is at 5 and then we have a constant number 7. Then over here, basically you need to find how much n is there. So the simple way is 5 minus 3 plus 1. This is the rule. This would be n. N is equal to, or you should count. 3 is one number, 4, 5. So there are 3 numbers, right? 3, 4 and 5. So multiply 7 times 3, or you can do this 5 minus 3 is 2 plus 1 is 3, and that will be the answer 21. So this is how we can solve it up. And last theorem is if you have constant numbers with a term over here, then leave the constant as it is, simplify the term, and then multiply the constant. We will apply all this knowledge in a problem now. It'll be much easier. Let's do the first one. Here, summation of I starts from 1 till 8 and 2i plus 1. This is a very basic problem. It's just like I and a constant. Sorry, there are 2 terms over here, this and this. But they are very simple, right? So what you do is multiply this inside. There is no I square or there is no term divided by square or anything. Little basic, you can say. Multiply this. It will be something like this. Summation I equals 1, 8. It will be 2i. Then plus summation I equals 1, 8, 1. This is the thing. And now use the, apply this. Basically, use the formulas. Don't go to write it all out. 2 times 1, 2 times 2. No, just apply the formula. This is a very simple formula here. It is, I'll write the formula. If it is I equals 1 to n. If it's only I, the formula is n into n plus 1 by 2. Now, if it is a constant over here, because I have constant next, I will just write this as well. If it is a constant c, it's c into n. You need to remember them formulas because if you're doing the calculator method, this can be directly done in the calculator. Do this thing, write this, write the formulas, and then directly write the answer. It's fine, but only if you directly write the answer, it's not good. You if it's in writing, you may lose marks. So write the substitution, simple substitution. I've just multiplied this inside, write the formulas, and then at least if you can't do the formula, put it in calculator. But this is so simple, so please try to write it out by yourselves. Now here n is 8, so what you need to do is 2 will be outside. Instead of I, what happens here? It'll be 8 times 9, because n into n plus 1 divided by 2. That's it. Plus, what about this one? It'll be 1 times 8. This is the formula. Here this 2 and this cancels out. It'll be 9 times 8. 9 times 8 is 72. Or 8 times 9 is much easier. It's 72. 80 minus 8. 72 plus 8, that is 80, and this will be the answer. Same thing over here. What you did just now, the same thing, but what's the difference? Here it'll be 800 and 801, and you need a calculator. Over here it'll be 1 times 800. It's just that 88 to 800 is jumped. Okay, so that's it. Now I will do the same thing in the calculator and show it to you. Use the shift and summation key, and now here there is no need of any brackets, so you can write directly alpha x plus 1. Please remember it's alpha x, not I. There's no i's option over here. And then 1 to 8, and here you go, that is your answer, 80. And the same thing, only if you change this to 800, you will get the answer. It'll take about 15 seconds because I'm not, this one will be more quicker, but my students had told me it was taking about 15 seconds at least in their manual calculator, and you will get the answer. I'm also taking almost the same time for some reason. Usually this computer simulation is quicker compared to the physical calculator. So here it's 80, and this is 641,600. 641,600. Now same thing can be applied over here, same method, very simple. Please do try to solve them as well. You can see over here it's 287. Now this is by formula. What is the formula used? Here it's squared, so it is 20 multiplied by 21. I'll just write the formula over here quickly. It is summation I, when I squared, sorry, I starts from 1 to n, right? The formula is n into n plus 1 into 2n plus 1 divided by 6. So here n is 20, 20 plus, n plus 1 is 21, and this is 2n. 20 times 2 is 40 plus 1, 41 divided by 6. That's it, and then you can just put in the calculator and get the answer. Here now, there are two terms. This is a constant, right? So square this up. It will become I square by 20 square, and take this 1400 outside and just solve. I is equal to 120 and I squared. Now it's much simpler to solve, right? We know the formula. Just put the same thing. Put it over here and solve it up. But both of them can be easily solved in the calculator. You can do it by yourselves and then check the answer over here. It should be the same answer. Now this part, I squared part, is the same both the cases. It's just that 1 by 400 is the extra part. Just solve it up. You must get these answers. Here in this problem, we have been given a function x squared plus 3, and then they have told x is 0.1, 0.2, and so on. Let us see if we can use a decimal point in this. It cannot. It'll show you an argument error. Even in the top, instead of n, if I have a decimal, it shows argument error. That means I need to have all whole numbers, only integers, and we are just using positive integers. So how can I incorporate 0.1 in this? It's simple. What you need to understand is how many are there, how many intervals are there, 0.1, 2, 3, and so on. If I count them, it's 1, 2, 3, dot, 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 10. Because 0.1, 0.2, 0.7, 8, 9, and then 1 would be the 10th interval. So there are total 10 intervals. I can directly write the summation. I equals, over here, 1 till 10, n is 10. But how do I rearrange this now? Can I just write x squared plus 3? No, this would be wrong. So what do I do? Here, because I know the starting value of x should be 0.1, now this x will be changed. X will become 0.1x. So if I make this 0.1 the whole square, then I will get the correct answer. Now it's simple. You can use the same rules over here. You can split this out. This is constant, this is square. You can square it out, take it out. We have done the similar type, right? The same thing. I'll do it directly in the calculator now. But this is the concept here. Instead of x, I need to make it 0.1. So if I just press shift and the symbol over here, we get 0.1. Now don't forget to use the brackets. I'll use the bracket here first. Then alpha x, close the bracket, square it up, plus 3, and then we are going from 1 to 10, and this is the answer, 33.85. You can see the final answer must be that. It's, yeah, 33.85. Now if I had not written the bracket, I'll show you over here. It makes so much difference because the answer is entirely wrong. So please make sure you write the brackets properly. That's how we solve that. But now what if the x values are not starting from 0, 0.1, 0.2, not like that. If it's something else, how would you solve it in this case? And the x is looking a bit complicated as well, but that's fine. This function doesn't matter, you know. This part, first is this part. Let us count how many are there. This is the first one, second, third. What is the jump? It's 0.1. Here also 0.1, 0.1. So the jump is being 0.1 over here everywhere. So what I can understand is if I start from 0.1 plus 0.1x, will that help me? So this will help you, but I need to rearrange the summation values. But the better way would be, you know that there's a jump of 0.1 over here, right? But how many are there? This is another important question. So there are, if you start counting, you will get 20 of them. Why? Because, see, from 0.1, this is counted, okay? And then you go next, 0.15, 0.25, 35. And imagine this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Ninth number would be the 10 digits total, 10 intervals, right? Because you start from 0. If you start from 1, 2, 3, 4, 5, 6, still 10. But if you look carefully over here, look at this part because it's 0.1, isn't it? So just focus on this part. You're starting not at 0.1, you're starting at 0.0 basically. So 0, 1, 2, 3, and so on till 9 will be 10 digits. And then next one again would be again 0, 1, 2, 3, and we are stopping at 9. Can you see this? So it's 10 over here, 10 intervals, 10 intervals. So total are 20 intervals. This is very important. The total intervals are 20, not 10. How you can notice it? See the interval, what is it jumping at? 0.1. So look at that 0.1 after the decimal, right? It starts at 0, ends at 9. But look over here, it's not 1.9. If it was 1.95, it would be 10 intervals. It's 2. So again, another 10 more. This is it. If you're getting confused for this one, you can just start counting it out. Next one would be 1.35, 1.45. Just write it all out and then count it. You'll get the same one. So now let us write it in terms of summation. Let's use the x denotation because over here it's all x. X starts with what? It starts with the 1. And how many intervals? 20. So now if you're starting with 1, the first interval, we must get this as the answer. We know we need to add 0.1x. Okay, that is the interval. That's the interval that's jumping. Now, what about this term? If I put over here 1 and if I write 1.05, I'm going to get the second term in the first itself. Now, I need to go back. I need to write 0.95 because if I write 0.95, then when I add the 1 over here, x as 1, then I'll get this term, the first term, so on, and the next terms. So this is very important to understand. If you're thinking, no, I need to write this term, then it's fine. Write 1.05 plus 0.1x. But just make sure over here, you don't start with x as 1. You should start with 0. Why? Because this will be nullified and you're getting 1.05 and so on. But then what is the top n value? You're starting 0th digit, so it'll be 19 over here. Okay, 0 to 9 is 10, 10 to 19 is 20 digits, 20 intervals. So this is how we do it. And now over here, we can just put them in the calculator. I'll show you, both must be the correct answer. I'm so sorry, this is not the terms. This is the x term. Basically, this is the x term. X is equal to 0.95 plus 0.1 x. So that is the thing. Now here the summation values are correct, just that I have to put it with the other variables, other terms, sorry, constants. So x over here is 0.95 plus 0.1 x the whole squared minus 4 times 0.95 plus 0.1 x plus 2. What about this? If you're writing it, it has 1.05, it's fine. Your terms over here, the interval changes. Then now let's write it 1.05 plus 0.1x the whole squared minus 4 times 1.05 plus 0.1x, no square over here. See, you should just follow this terms over here. Instead of x, we are substituting this values. And last one is just plus 2. Now all you need to do is substitute over here by pressing shift alpha x. Now make sure you put the brackets properly. The brackets over here needs to start 0.95 plus 0.1. It's 0.1 or 0.1. It works. Alpha x. Now close the bracket and square it up. Now minus 4, it's fine, but now again use the bracket 0.95 plus 0.1, that is 0.1. If you don't want to write 0, it's fine, you can write directly 0.1, you will get the correct answer itself. Close the bracket plus 2. This is your, see, now I have not written the x values, that is so silly of me. So it's 1 and 20 over here, and the values must be 139.95. I think so that's the correct answer. But anyways, we will check this as well. This also must be 139.95. All you need to do is change over here a little bit. It'll be from 1.05. And then it goes on 0.1 x squared minus this also again it changes 1.05. And then the last part remains the same. Here what happens is you need to put 0, and here it'll be 20 minus 1, that's 19. And yes, we got the same answer, 139.95. So the final answer is yes, you can see it's 139.95. And that is the end of it. I humbly request you all to share my videos with your friends. That would mean so much to me. And please hit the thumbs up, hit the like button. That would be greatly appreciated by me. And I wish you all the best for your studies. Please do practice more problems, solve more problems by yourselves. Until the next video, I wish you all happy learning.